This is Mrs. Palmer-Quay with the fourth video for Module 5. In this video I will start talking about the first math of chemistry as we convert between particle, moles, and grams. Let's start by reviewing. Remember that the word mole refers to a certain number, and that number is 6.022 times 10 to the 23rd. And this represents the number of particles, be it atoms or molecules or ions, in a certain amount of an element. And that element for 1 mole is the atomic mass of that element measured in grams instead of AMUs. And if you're not quite sure how this all works, go review the previous video where I talk about it. I didn't say this yet, but I want to tell you now that the coefficients that are in chemical equations can be understood in two different ways. We can understand them as representing individual particles being combined together, or moles of particles being combined together. So if we use our equation for water, where we take hydrogen gas and add to it oxygen gas and end up with gaseous water, water vapor. We start with our skeleton equation. A quick glance will tell us this is not balanced because we don't have enough oxygen on the right. So we have to add a coefficient of 2 in front of the water molecules, which gives us a few too many hydrogens. So we need to put another coefficient over here in front of the hydrogen gas on the left side. Now our equation is balanced, and we can read it that there are 2 molecules of hydrogen gas plus 1 molecule of oxygen gas, giving us 2 molecules of water, or 2 moles of hydrogen gas plus 1 mole of oxygen gas give us 2 moles of water. So those coefficients can either be individual particles or moles, and actually more often we are talking about them as moles because atoms are just so tiny we can't deal with individual particles. We need handfuls, we need moles of atoms to work with. One way to think about the math is to think about what happens when you're going from moles to anything else. So we can go from moles to number of atoms or number of particles. This chart just happens to use atoms. Or we can go from moles to grams. And whenever we're going from moles to something else, we're going to be multiplying in order to do that. So we multiply when we move away from moles to something else. But if we're going from that other thing to the moles, we can set it up as a division problem. So that might help you keep things straight. That going from moles to something else, you multiply, and those are all m's. Multiplying and moles are all m's, whereas coming from something else to moles, we are needing to divide. Now, of course, dividing can be multiplying by a reciprocal, and so in any case you can do it all by multiplication. But this chart might help you keep things straight. Let's start with a particle calculation. This question asks us how many carbon atoms are there in 0.750 moles of MSG. Here's our formula for MSG, and you see for every molecule of MSG you have 5 carbon atoms. So we know that information. We've got 5 carbon atoms in every molecule of MSG. And we also know that we have 0.750 moles in our sample. So then what else would we multiply by to give us an answer that would tell us how many atoms we have? Well, we want to, in how many molecules of MSG are there in the mole? We're trying to cancel out all these units. So in each mole, we know that we have 6.022 times 10 to the 23rd MSG molecules in each mole. And so if you set up your equation properly, the unit that you are looking to find should end up in the numerator. And so here we are canceling out our moles, and we're canceling out our molecules of MSG, and so we're left with our atoms of carbon. And if you multiply the 5 times the 0.75 times the 6.022 times 10 to the 23rd, you get an answer of 2.26 times 10 to the 24th. And of course our units are carbon atoms. And so this is the kind of calculation that you might be asked to do to talk about how many particles are in a particular sample size. But in reality, most of the time the calculations are like the ones that we're going to do next. much more often you are asked questions that want you to figure out how many grams of something there are in a certain amount of moles. So this question asks how many grams of magnesium are found in 0.457 moles of magnesium. In order to answer that question, we need to go back to the periodic table. So I have my sample periodic table block here, and it tells me my atomic mass for magnesium is 24.305. And so we know then that there are 24.305 grams of magnesium in a mole. And we are wanting to know how many grams are there in the 0.457 moles that we have. So setting up the problem this way, you see we're canceling out our mole units. We are left with grams, and if we multiply the numbers through, we find that there are 11.1 grams of magnesium in our 0.457 moles of magnesium. So in this case, we want to think about, we're moving from moles to grams, and so it's a straight multiplication problem. We've got our mole information, and we go to the periodic table to get the atomic mass information that tells us how many grams are found in each mole. We also need to be able to calculate the number of grams in a mole of a compound. So this question asks, what is the molar mass, the number of grams in 1 mole, of the compound copper sulfate? And so I don't have individual periodic table blocks here. You'll just have to trust me that you go back and look up copper and see that the atomic mass of copper is 63.5, and then look up sulfur and find the atomic mass of sulfur is 32.1. And so of course these as gram measurements are giving us grams per mole, not thinking about AMUs, but thinking about them as grams per mole. And then oxygen is 16.0 grams per mole, and we have 4 oxygens in every molecule. So you have to pay attention to what the subscripts are in these formulas so that you are able to multiply your individual elements' molar mass by whatever appropriate subscript you have. So if you go ahead and do all of this multiplication, multiply 4 times 16 to get 64 and add it with everything else, you will find that 1 mole of copper sulfate would mass at 159.6 grams. So if you, or grams per mole. So if you want to measure out 1 mole of copper sulfate, you've got to measure out 159.6 grams. How about if we have to go the other way? How about if we are given grams, but we're asked to find moles? We have an amount of 50 grams of sodium, and how many moles are in that? That's the question. So we have our sample size of 50 grams. And remember, one way I said to think about that is if you're going from something back to moles, you can think about dividing it. What are we going to divide this by? We have so many grams. We're going to divide it by how many grams there are in a mole, the molar mass. So for sodium, it's 22.99, according to this table, at least 22.990 grams per mole. Now, if you know anything about stacking fractions, you know that the something per mole actually means we're multiplying this. It'd be the same thing as having 50 grams over 1 being multiplied by 1 mole over 22.99. So, as I said, the multiplication is multiplying by the reciprocal when you have fractions, and so we have a number over a fraction here. But whichever way is easier for you to think about it in this multiplication line like this, or to think about it in this division line. It doesn't matter because you end up getting the same answer. So if you go ahead and do the math, you'll discover that you have 2.17 moles in this 50-gram sample of sodium. And finally, what if you're working with a compound? This question asks how many moles are there in 125 grams. This is of carbonic acid, H2CO3. So it's just like the copper sulfate example. You have to start with figuring out what is the molar mass of this compound. So we've got hydrogen and carbon and oxygen. Hydrogen, if you look on the periodic table, you have 1.01 grams per mole. And of course, this is going to have to be multiplied by 2 because our subscript tells us that there are 2 hydrogen in 1 molecule of this compound. And carbon is 12.0 grams per mole, and oxygen is 16.0 grams per mole. And of course, you've got to multiply it by 3 because your subscript here says 3. So if you go ahead and do all of that multiplication and then add up the individual elements, you'll find that there is 62, and we'll just stick to one decimal point here, 3 significant figures, 62.0 grams in every mole of carbonic acid. So your question is, you've got 125 grams. And so, again, you can think about dividing this into 62, sorry, I wrote 66, 62 grams per mole, or you can think about multiplying 125 grams by 1 mole over 62 grams. Whichever way works best for you so far as how you think about math. But if you do all this and do the work, you'll find that you have 2.02 moles of carbonic acid in those 125 grams. So just to go back to this chart, just to review one more time, if you're going from moles to grams, it's a very simple multiplication, going from moles to something else. If you're going 2 moles from something else, you are either going to think about dividing it or you're multiplying by the reciprocal of your molar mass so that you have your units in the right place when you get to the answer. Those units need to be in the numerator, not the denominator, in order to be correct. So this covers what I want to say on this video about calculations. We're really just getting started on math for chemistry. We'll be doing lots more calculations as time goes on.